Oh, sir, you're live now. You can start.
हाँ ठीक है. Okay, so yeah, I think so. I'm seeing 9 are watching now. So if you have any questions, then maybe you can ask, and so we can discuss here. Okay, yeah. So I'll see. So I see the first question by Ellen. Just one second. Okay. Yeah. So can you suggest some good books? Sure. Yeah. So I think so. I've been mentioning a couple of books, right? I mean, so one is by Shamwe Stouffer. So if you want, I can write it down. So and I think I mentioned them even before. So Shamwe and Stouffer is a book, good book, which is kind of basic also. And one more would be, let's say, Brockwell and Davis. Uh, yeah. So again, these are kind of basic time series books, and then I guess Shamwe and Stouffer have some R applications also. Okay. And apart from that, there's a very good book by Rui Say. So this is on financial time series, basically. So if somebody is interested in financial time series, so probably he or she can look at this one. Yeah, same answer to Anurag. So Anurag, I will say that Shamwe and Stouffer try to pick it up. Uh, I mean, it has some R applications and all that, right? And it'll be kind of end to end. So if you are kind of missing any section also, then it'll be good if you go over that book. Yeah. Anything else at all? So maybe you want to discuss something, something like that. So by the way, there is one question I'd like to answer. There was one question in the response sheet by Ravindra, and maybe I'll answer it here because so even if he's not here, maybe if he gets access to the live session sometime later, then he can basically look at the answer. So his question was that can you explain a particular model which is called as FCAR in time series? So FCAR stands for functional coefficient autoregressive model. So slightly outside of what we're trying to study because FCAR model is kind of a non-linear model. So hence we did not have time to pick it up in this session of ours. So the whole point about FCAR is, let's say if you have an autoregressive structure with some non-linear covariates. Okay, so it's more like a regression kind of a setting. All right, and then if you have some non-linear covariates, let's say xt, or rather set of xt's along with a time series variable yt, then how do you build that model, and how do you estimate that model, and how do you forecast from that model? Okay. So slightly different kind of a model, more from a non-linear perspective. Okay. Yeah, so I think one more question by Ellen. So these books also cover frequency domain. Yes, yes, yeah, they do. Okay. Anything else at all? Or- Yeah, thanks, Aline, for the motivation. So I'm not sure what session is going on this week. So is it the non-linear time series one, or so I think we're almost there, right? So maybe a few other ideas would follow. So machine learning in time series and so on and so forth. Okay. Garch aside, okay, yeah, all right, yeah, thanks. For the machine learning, are these references also covering this? Not quite. So for machine learning, I'm not sure if you have any proper textbook to follow, but I mean, what we do is we follow some recent papers, basically. So if you're more inclined towards research and all those things, right? I mean, my suggestion is to pick up some basic papers, right? Let's say start with some very basic integration of regression and time series, then classification problems and random forest decision trees, all that. I mean, of course, you do have some references which are kind of standalone, but not a proper extensive textbook per se. Yeah. Good morning. So the question by Sahir. So any suggestion to refer for Bayesian models? Also to learn doing with Python for machine learning and Bayesian models. So are you talking with an integration to time series or generally? So Bayesian models, they can pick up any basic statistical applications book, right? And for Python, I mean, you have to do some search because even I'm not sure about the recent books, right? So try searching for, let's say, a good book on Python applications plus Bayesian models, and on top of that, if you want some time series integration, then which one? So I'm not able to recollect, kind of, but I can recommend. So maybe send me an email or something like that, right? And I can reply. Yeah. Uh, yeah, good morning, Noreen. So, can you please suggest any referral material for spatio-temporal analysis? Yeah, again, like I said, I don't recollect a concrete book, but so you have many recent books by a particular publisher. I'm forgetting the name, where all these independent areas are dealt with applications in R. So again, one suggestion is that just send me an email maybe. So okay, so on my you can get my details on my webpage and send me an email. I'll reply this. So I'll search and then tell you some good texts. Okay. Yeah. Yeah, so there's one more question. How can we check data is normal or non-normal? So you have statistical formal techniques for that. So you have tests like, let's say, Shapiro-Wilk, Kolmogorov-Smirnov. So you create that hypothesis testing problem uh, to basically test if the data is normal or not, and then you bring in the sample, and then it gives you a p-value, right? And otherwise, also you have some visual base. So let's say histogram is a very basic idea, and the thing called as normal QQ plot. So quantile plot. Okay, so these are some of the techniques, and you have many more also. Can we have a clear example for EWMA? Yeah, sure. So exponential weighted moving average, right? So let's say if you are into stock price forecasting, okay, and so let's say if you want to fit some moving average on that. So moving average captures the average of the last few entries, right? So let's say if you are doing some, you want to forecast the closing prices, for example, Reliance stock, okay, and you want to forecast the closing prices for the next couple of days. So I can actually fit number of different moving averages. Now, what EWMA does is it puts more weight to the recent observation. So recent in this case would be yesterday's observation. All right, and then it puts slightly lesser weight on day before yesterday, slightly lesser weight on in that order. All right. So what happens is it's more like a weighted moving average. So weighted moving average gives more weight to recent activity and lesser weight to the activity which has passed, let's say, 50 days back or 20 days back, and so on. So, in a way, it reflects the actual scenario in a slightly better manner, right? Rather than a simple moving average. Yeah, any other question at all? Otherwise, we can close it in, let's say, 10 minutes or something. Yeah, maybe if you have any last minute questions, you can ask. Otherwise, we can close it in 2 minutes, probably. All right. So I think we close it now. So since I'm not seeing any question, which is again a good thing, of course. And I think there'll be one more live session, maybe sometime next month. Okay. So there, if you again have any queries, you can clarify. Hmm? All right. So
Okay, sir, so we're closing now. Thank you.